Okay, I apologize. I have a sinus infection, which is affecting my voice. I'm sounding a bit like Kermit the Frog, which is awful, but we need to get this lesson out there, so we're suffering through. What we're going to do today is we're going to work on rewriting radical expressions by using rational exponents. When I say radical, I mean like square roots or cube roots, etc. We're also going to simplify and evaluate radical expressions and expressions containing rational exponents. These two vocabulary words, we need to understand the difference between the two so we can talk in the same language. All right, you're probably familiar with finding the square root of a number. These two operations are inverses of each other. Similarly, there are roots that correspond to larger powers. So, for instance, I have 5 and negative 5. They are square roots of 25 because 5 squared is 25 and negative 5 squared is 25. 2 is the cubed root of 8 because 2 cubed is 8. 2 and negative 2 are fourth roots of 16 because 2 to the fourth power is 16 and negative 2 to the fourth power is 16. A is the nth root of b if a to the n equals b. So this right here is what we need to sort of remember if you're having a hard time keeping everything organized. It's sort of like the difference between log and exponent, if you might want to think of it that way. To keep going through our vocabulary, hold on, we lost part of our slide. So the nth root of a real number, a, can be written as the radical expression. We'll go right up here. N root a. So the nth root of a real number a can be written as the radical expression nth root of a, just like the arrow shows, or n, excuse me, is the index, plural indices, of the radical, and a is the radicand. So just try to remember n is the index, a is the radicand. When a number has more than one root, the radical sign indicates only the principal or positive root. So when a radical sign shows no index, it represents a square root. So when you see something like this, n is equal to 2. It's a square root. Okay, when it shows no index, there is nothing right there. It means that there's a 2 there. Just like when you would see a log with nothing, that means that it's really, so like log of n, that means it's really base 10, right? If there's nothing written there, it's really base 10, same deal. So the property of square root in lesson 1.3, which was so long ago, also applies to nth roots. For instance, the product property of roots. The nth root of a product is equal to the product of the nth roots. So, for instance, I have the third root of 16, or the cubed root of 16. It's the same as the cubed root of 8 times the cubed root of 2. I can actually take the cubed root of 8, which is that 2 right there, if that makes sense. But I can't take the cube root of the 2, so that simplifies to 2 cubed roots of 2. In algebra, they just split it up. Quotient property of roots. I have the square root of 25 over 16. I can split that up into the square root of 25 over the square root of 16, which I can take the square root of, 5 over 4. So the nth root of a over b equals the nth root of a over the nth root of b. Now here's your friendly reminder. When an expression contains a radical in the denominator, you must rationalize the denominator. To do so, rewrite the expression so that the denominator contains no radicals. We've done that with just square roots before, but now we have to do it with cubed roots, fourth roots, etc. All right. Simplify each expression. Assume that all variables are positive. Let's work through this. Now there's a few ways to think of it. So if I break this up into little pieces, it might make sense. So we're going to do this one very basic. 81, let's see, I have a fourth root here. 81 is the same as 3 to the 4th power. And x to the 4th I can break up into, x to the 12th I can break up into x to the 4th 3 times. Because remember, 4 plus 4 plus 4 is 12. Okay, now if we even break this up further, I have the product property. So I have 3 to the 4th, 4th power of x to the 4th, 4th power of x to the 4th, 4th power of x to the 4th. Okay, that all simplifies to, when you see these two things match, 4th root of 3 to the 4th power, it simplifies to just 3. Again, these two things match. I have x, x, and x, which gives us 3x to the 3rd power. Okay, let's try another one. I'm going to try each of these problems in a little bit different way in hopes that you'll grab a way that you like, that you can work the problems. Okay, here we have that quotient property, and we're going to have to rationalize. So I'm going to split it up into the 4th root of 16 x to the 8th over the 4th root of 5. Okay, now the 4th root of 16, that's the same as, I have 16 is the same as 2 to the 4th power. And 8 is the same as, x to the 8th is the same as x to the 4th times x to the 4th. So this top, the numerator simplifies to 2x squared over the 4th root of 5. I can't do anything with the 4th root of 5, but I do have to rationalize it. Let me change colors here. So how many 4th roots of 5 do I need before I can actually take the 4th root of 5? 4 of them. So I'm going to multiply this by the 4th root of 5 3 more times. Okay, now when you multiply, you have to multiply by 1. So really, now the numerator is now simplified. The denominator is now simplified. So I have, 2x squared times the 4th root of 5 times 5 times 5 is 125 over, I have the 4th root of 5, 1, 2, 3, 4 times, so it's over just plain old 5. And we are done. Okay, you try this one. Go ahead and simplify the expression. All right, so 16 is the same as 2 to the 4th power. And x to the 4th, remember when these two exponents match, when these index and the power match, it just goes to x. So that was an easy one. Okay, try another one. Here we're going to have to rationalize. Okay, x to the 8th is the same as x squared 4 times, so the numerator simplifies to just plain old x squared. The denominator needs to be rationalized, so that 4th root of 3, I need to multiply a total of 4 times, 1, 2, 3, 4. And when I multiply denominator, I have to multiply the numerator too. So the numerator, 3 to the 3rd power, is 27. So that's why the numerator simplifies to x squared, 4 roots of 27. The denominator just goes down to 3. All right, one more. That is a multiplication sign. I had a little formatting error there, I apologize. But here we're going to do the product property of roots. So let's do this one together rather than it being a you try. They're both cubed roots which means underneath I can multiply them. Okay, and remember the exponent rules. When you're multiplying the same base, you add the exponents. So it's x to the 9th. Okay, x to the 9th is the same as x cubed 3 times, which means our answer is just plain old x cubed. Okay, a rational exponent is an exponent that can be expressed as m over n, where m and n are integers and n will never be 0. If n were 0, that means it will be undefined. Radical expressions can be written by using rational exponents. So first, for any natural numbers n and integer m, the exponent 1 over n indicates the nth root. Okay, so if it were 1/2, it would be the square root. 1/3, the cubed root. Here we have an example, 1/4, the 4th root. Okay, so the algebra is a to the 1 over n is the nth root of a. Okay, the exponent m over n indicates the nth root raised to the mth power. I wish they would use other variables than m and n. They're very difficult to say clearly. So here we have 8 to the 2/3. The 3 is the root. The 2 is the power. So the 3 is the cubed root of 8, which is 2 raised to the 2nd power, which is 4. So I have a to the m over n is the nth root of a raised to the mth power. The denominator of a rational exponent becomes the index of the radical. Okay, so that is your n. Denominator is also your index. All right, write the expression negative 32 raised to the 3/5 in radical form and simplify. Okay, we have 2 methods to do these, and we'll do them each time. First, we're going to evaluate the root. So I have the 5th root of negative 32. 32 is actually 2 raised to the 5th power. Okay, mess around with your calculator, and you guys can figure it out. 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of negative 32 is 2 raised to, it's negative 2. Raised to the 3rd power is negative 8. Okay, method 2, you can actually evaluate the power first, the m. Okay, negative 32 cubed, type it in your calculator, it's actually negative 32,768. Okay, the 5th root of that is negative 8. I personally think method 1 is much easier. Okay, let's try to check it out. Do whichever way that works, and we'll get an answer at the end, so push pause. And there we go. Try 2 more, or 1 more, sorry. 4 raised to the 5/2, 2 methods. And there you go. Try 1 more time. I'm not sure how method 2 would be easier in this case. That's just crazy. But I hope it gives you a better understanding of how the numbers all work together. We're going to actually stop there for today and finish it tomorrow.